Okay, for today, I'm going to just quick remind you how that lab worked where we are trying to figure out how fast the drone was going. Okay, we knew how far it went, and we know how much time it took. So I'm going to do one in class. I just paced off 15 feet. Okay, now I want you to time me. See how long it takes. You have a timer on your iPad. If you don't know that, you can look up timer if you search for it. Anyway, get your timer up. Are you ready? And I'm going to have you time me. I'll say on your mark, get set. Okay. On your mark, get set, go. Stop. Okay, how long was that? 3 point. Okay, now this is interesting. Somebody said 3.3, somebody said 3.7. What else we got? 2.7? Seriously? What'd you have? 2.78? So you guys are within a full second off from each other. All right. Who said it was under 3? Raise your hand if it was under 3. That's most of the class. Who said it was over 3? All right. So I think more people said under 3. How about we just say it's 3? All right. My life will be a lot simpler then. All right. So we'll say it's 3 seconds, and then that goes on the bottom. And notice the units are important. And then how far did I go again? I pasted off for you. 15 feet. 15 feet in 3 seconds. Now, yeah, you can reduce that if you want to, because we use nice numbers there. But you don't even have to. That's not the key to the question. The key to the question is multiplying by the right factors. These are called conversion factors. In science, they might call them something else. But you're going to learn this in science, too. And the cool part is, compared to the other kids sitting in there, you'll be like, oh, I know how to do this. This is easy on that day in science. All right. Do you get I want seconds to be on top in this little one, because then I can get seconds to cancel, see? All right, so what's a fact you know about seconds? 60 seconds, 1 min. All right, that's a good one. Now seconds are gone, and now my units are feet per minute. Is that what I want them to be? No, I want this to go to miles per hour. So who's got another one? You got one, F? 60 minutes, and then I know where I have to put that. Where do I have to put 60 minutes? On top, because that way they'll cancel. You always look for the units. See, these and these need to cancel. There, but wait a minute, I gotta have something on the bottom. What's a fact I know about 60 minutes? 1 hour. 60 min, 1 hour. Minutes is gone. I now have feet per hour. I'm close. I wanted miles per hour. Can you do the last one? Do you have it memorized? And where should I put it? On the top or the bottom? On the bottom. 5280. If you haven't memorized it yet, memorize it. It's a powerful one. It's going to be used in honors pre-calc next year. Don't say I didn't warn you. Okay. And then that's 1 what? Mile. All right, so essentially, that's all you had to do for the lab. Feet cancel feet. And now you multiply across the top, multiply across the bottom. Go ahead and do that. If you've got a calculator on your iPad, figure out how fast I was walking there. It was kind of a normal walking speed. And yeah, you could have said I was going 5 feet per second. But what is that in miles per hour? That's what we're figuring out. Because I was just multiplying by 1 the whole time, the amount isn't changed. It just has different units. My speed is still the same. 5 feet per second is still the same speed. We didn't increase it with all this multiplying. But we changed it to different units, and who's got an answer? Raise your hand if you got the answer. Okay, only 2 people have the answer. I'm going to pause for a minute while you guys figure it out. Did you get a number? By now you should add a number. Okay, if you don't know what to do, all you have to do is 15 times 60 times 60. And then on the bottom you go 3 times, do I really need to times by 1 times 1? No. And then times by 5,280. And then I got a number on the top and a number on the bottom, and then I divide them. What did you get? You thought everybody else was going to do it? Okay, how about this? What did you get? 3.4. Can anybody verify that number about? All right, I'm getting a lot of hands. About 3.4. All right. So that means about 3.5 miles per hour was what I was walking. Now, I want you to think about that for a second. Does that mean that when I started, my speed was instantly 3.4? Probably not. Do you get I probably sped up? So do you get at my peak speed? I was probably going a little faster than 3.4. Because at the beginning, I wasn't going 3.4. When I first started, like just to get your leg going in the right direction, you're going to start out slower, right? So my peak speed is different than my average speed. Get what I mean? If you have a car, it goes from 0 to 60, okay, in a certain number of seconds. When it starts, it's actually going pretty slow at the very beginning. By the end, it's roaring fast. It's probably going, 80 miles an hour or whatever at the end. But at the beginning, it's going 0 miles an hour. It's an average. All right. So the best advice I can give you on the lab is follow the directions. It says right on that sheet what I want. If you don't have a thing that's called purpose, if you don't actually do a purpose, you're going to lose a point. It said to do a purpose. What was a purpose? In words, I could make it really simple. It can be your own words, but find the horizontal and vertical speed of the drone. That would have been good enough. Okay, and then sketch. It's asked for a sketch. You don't have a sketch, automatic points off. Does it have to be beautiful artwork? No, but it should have the basic, idea of a drone and what direction it's going, and maybe labeled with something. Yes? Mm-hmm. All right, so let's say this is a terrible blade, but let's say that is the propeller blade. Okay, and I was saying a little spot on the tip of the blade would go around and around and around, right? It's 5,000 rotations. And a rotation means that when it goes around in a circle, it follows that path. And so how far does this little tip of the blade go? Well, it does 5,000 circles in 1 minute. So that's 5,000 rotations per 1 min. And what is a rotation? Well, I'd want to make that one rotation down here so that these rotations can cancel. But what is one rotation equal to? Well, that's a circumference, right? And so you can get the circumference. The circumference is a little formula for circumferences. That's the part you have to figure out. I did tell you the radius of the propeller was 4.75 inches. So, all right, that's about as much as a hint as I can give you there. Is that good enough? Yes? I get what you're saying. If you are multiplying by a true fact, which would be that there's 3,600 seconds per hour, I think, right? Then that's okay. You don't have to have two separate factors. Yes?
For the circumference formula, are we using pi or just
Pi is more accurate. I'm not going to mark you down if you round pi to 3.14. But yeah, calculator has a button for pi. Ideal world, just use the button for the calculator's button for pi, because that will give you more than just 4 digits, and yet it doesn't go forever, so it's kind of a reasonable compromise. Because pi, actually, you can't give an answer that's perfectly accurate using pi unless you leave the letter pi in it. You know what I mean? All right. But the 3.14 is fine. Okay. Enough about that. Now let's talk about what are you supposed to be learning about imaginary numbers and stuff. Let's just go back to the beginning. When you have a quadratic formula, which we're going to do more of in the next chapter, you sometimes get this kind of a thing going on at the end of the problem. And it's possible sometimes that this number can be negative. And then in the old days, we would say, oh, can't have negatives under the square root, therefore no solution. But do you get now? You can handle it by throwing an I in there. All right, let's do one that's just a little easier than this one. Let's make it work out nice, except that it's got a negative. Like, for instance, negative 16. Would you please start with that problem? You should be able to do this by now. You've practiced it in the top 20 enough. And the only thing that's really different is you have an I thrown in. Now, I'll pause for a second and walk around and see how you're doing. Okay, wait. I'm gonna actually put 3 problems up, and then give you a little more time. Okay, so that's one problem I'd like you to try. Here's another one. What if I had I I'm just going to remind you, I squared was equal to -1. Do you remember that? So you can use that fact along with that, of course, I to the first power is just I, to answer things like, what in the world is I to the third? Well, you'd say it's I squared times another I. Does that ring a bell? We did this before, right? And then what's I squared equal to? -1. So this is -1I. All right, so I want to know, what's I to the third plus I to the seventh? It's supposed to be a 7. What's I to the third plus I to the seventh? Well, first figure out what I to the third is, then figure out what I to the seventh is, and then put them together. All right? And then the last part is, if you had to solve this, I'm going to pause for a second. 2 plus I times 3 minus I. Remember, when you multiply that puppy out, you're going to get an I squared in there somewhere. And you got to remember what to do with it. Be really careful with your negatives and stuff. All right? I'm going to call these questions A, B, and C. I'm going to give you a few minutes. You should know how to do them, and I want you to check them with the kid next to you. Or even work with them on it if you want to. I'll pause while you do that. Okay, on that top one, first of all, do you get that the square root of -16 is 4i? Raise your hand if you knew that that was 4i. Good. Now I'm going to break it down a little further. I'm going to write 2 plus and minus 2 times 2i. You don't have to do this way, but I like it this way. What I do, I just broke up the 4i into 2 times 2i. And I break up the 6 into 2 times 3. Why am I doing all that? Because then I can see that this will have a 2 in it, and the bottom has a 2 in it, and those 2's are going to cancel. So my next step would be, I'm going to write this out as 2 plus and minus, oh wait, I need to factor that out, sorry. 2 comes out to the front, 1 plus and minus 2i, all over 2 times 3, 2's cancel. There's your final answer, 1 plus and minus 2i over 3. How many of you got that one right? Awesome. Okay, next up. What is I to the third? I would break it down into I squared times I, which makes -1i. What is I to the seventh? I'd break it down as I squared, and I squared, which is 3 negative ones with an extra I. So that's -I. That's -I. What's -I plus -I? -2i. I think some of you might have squared it at the end or something. -I is this first one. This is -I. This is also -I. What's -I plus -I? -2i. Okay. Any questions? Yes?
For that one, so I squared is -I.
Nope.
No, it's not.
I squared is -1.
Oh, that's right. -1.
Okay.
And then
So this is -1.
another -1.
Just hold on. That's not another -1. That's just an I.
Okay.
I squared times I makes I to the third. Here's another way to say it. I squared times I to the 1 makes I to the third. So this one's a -1. This one's not a -1. This one's just an I. It's not an I squared. If it's going to be to the third, do you get I can't have 2 I squares? That'd be to the fourth. So one of them's an I squared. One of them's just an I. So it's -1i. All right. And then this last one. Yeah, either FOIL it out or just multiply this part and this part and that part and that part. That's a totally good way to do it. Doesn't matter. Get the same answer. 6, and then the outside and the inside makes plus 1i. I'm just going to say plus I. Why? Because one of those is positive 3i. One of them's -2i. And together that makes I. And then the last one is minus I squared. It's important to have that minus there and then know that just I squared is -1, which makes it negative of -1, which makes it a positive 1. then it's kind of picky, but you should really put the 7 first and say 7 plus I. If you said I plus 7, I wouldn't have marked it wrong, but do you get you're supposed to have the real part first and the imaginary part second? 7 plus I is better than I plus 7. Okay. Yes? All right, I know why. I think I know why. It usually is in this area right here. Did you get positive I right in the first time you multiplied it out? And that should have been positive I because a positive 3i was bigger than the negative 2i. So it should have been a positive I in the middle. Okay. There, that was some of the toughest stuff. And the test still isn't even on Monday. The test is on Tuesday. Okay? So we have one more topic to get through for today. And I would like you to find the smartboard for today. It's green. It says solving. Looks like that. Solving with complex numbers. Find that. In a moment, I'm going to ask you to turn it my way. You don't have to yet. Just pause for a second while people get caught up. All right, we found this spot. And here is a nice, simple question. It has a totally easy way to screw it all up. Let me show you how people do it wrong first. This part's okay. X squared equals negative 4. And at that moment, some people go, oh, something squared can't equal a negative, so there must be no solution for this. Wrong. We can do square roots of negative now. So we square root both sides. And then we get absolute value of x. Now that's the part where a lot of people are like, what are you talking about? It's supposed to just be x there. And then they think that this is plus and minus 2i, and it's totally not. Because on the test, if we just ask you what's the square root of negative 25, you can't say it's plus and minus anything. That's just 5i. Square roots don't have two answers. Get that straight. Okay, and I got to prove that to you because, again, I know some of you, when you learned this, you learned it wrong. Your teacher told you that this square root of this is x, and the square root of 81 is 9 and negative 9. Totally wrong. And I got to clarify why those teachers thought that and why you need to be smarter than that. Okay, so right now, I'm going to have you grab your graphing calculator. If you don't have your graphing calculator, you need to slide next to somebody near you that has their graphing calculator. I want you to type in this, square root of x squared, on your calculator. I'll pause while you get that up on your calculator. Square root of x squared. Okay, get that up on your calculator, and I can be okay with Desmos. Square root of x squared. It's really, really important that you see this, because you're going to be told by other kids even in other hours that the square root of x squared is x. It's totally not x. If it was just x, then the graph would be y equals x. I'm going to even graph that on a different line, because on my calculator I can show you the difference between y equals x and y equals x squared. Okay, if I hit graph now, I got two lines there. Do you get that the red one there is y equals x? Is that what the answer was? That's not what it was. I'm going to go back here, and I'm going to delete that back out again, because what I really wanted was just the square root of x squared. What is the square root of x squared? It's that. And what is that? The absolute value of x. See, it is an absolute value. So when you are doing this problem, you really need to get that the square root of x squared comes out to absolute value of x. Now the other thing is, kids still think, okay, but the square root of 16 is actually 4 and negative 4, isn't it? Let me show you. Now replace your graph with this, y equals square root of 16. We'll see if it's positive 4 or negative 4 or both of them. So go back to your y equals. Do square root of. And change this to 16. Square root of 16. I think we all know 4 is involved. But is it 4 and negative 4? How am I going to know? I hit graph. And look at that. My answer is a positive 4. Y equals 4. Does it have a line at y equals negative 4? No. So it's not both things. If it was, there'd be a line down there. Yes? Okay. If we look at the plots, 9 times out of 10, it's because you have a plot that's darkened in up here. Turn your plot off, and I bet it works. If not, I will come and look at yours in a moment to try to fix it for you. All right. So, moral of the story is that when you are doing this problem, you cannot do this. Square root of x squared is x, and this is plus and minus 2i. No, that does not get you credit, because the square root of x squared is the absolute value of x. I just showed you. I proved it to you. And this is 2i. So then how do you get the final answer? You break the absolute values. Always have 2 separate equations to solve. And here's what they look like. Without the absolute value bars, x equals 2i. Then you copy this over again, and obviously it won't be the exact same thing, or that'd be craziness to try to solve it twice. What's different between this equation and this equation is that there's got to be a negative right there. So final answer, x equals 2i, and x equals negative 2i. And people that shortcut that and just think, well, the square root of 16 is just 4 and negative 4. Nope, not going to give you credit. You have to learn this. Okay, so one more that's very similar to that. X squared plus 9 equals 0. Everybody solve that properly, including an absolute value at the right moment. And then we'll see if you've got that one down. I'll pause while I go fix the calculator. Okay, you should have started by subtracting 9. And then it's smart if you notice that something's weird, that something squared is equaling a negative. Then at least you'll know, wait a minute, something's weird here. It is weird, but it's not impossible. It's square root, and the square root of negative 9 is 3i, and just 3i. Okay, and then the square root of x squared is the absolute value of x. And the people are not listening to that and think, oh, I can just slap plus minus on there. You're going to do it on the test. You're going to see square root of, like negative 9, and you're going to think plus and minus 3i. It's wrong. It's just 3i. Okay, anyway, now back over to here. Absolute values give you 2 answers. You can make 2 equations here. X equals 3i and x equals negative 3i. And I'm aware you could have shortcutted that answer and did it completely wrong and yet got the same thing. But if you don't show your work right, I'm not giving you the credit. Raise your hand if you had it that way. Okay, good. If you didn't, you need to learn that now. Square root of x squared is the absolute value of x. That's why it was a V shape when we graphed it. That's why it looked like this, because it's an absolute value graph. That's why this absolute value of x is here. Okay, so now let's find some more. That one. It's just got a little more complication. You still start by subtracting something. I hope you subtracted 36 from both sides. And then you got this. And again, people that think that you're going to get plus and minus, they're going to get all goofed up here because they want to have an absolute value problem. You should get an absolute value next. You square root, square root. I kind of went over the top of my negative. I'm going to try that again. There we go. And I get absolute value of x plus 2 equals 6i. Then write the 2 equations. Remember, they're identical except for one negative sign. Okay, let's see if you did it right. You break it in 2 The first one, you copy exactly what you see, but no bars. X plus 2 equals 6i. And then the other one's identical, except it's got a negative. X plus 2 equals negative 6i. Now you subtract 2 from both sides. Minus 2, x is 6i minus 2. And minus 2, x is negative 6i minus 2. Those that have been following on the top 20, it's identical. If you had done the hard work to learn your top 20 by now, you already have this down. The only thing that's new is an I. Other than that, it's identical to what we've been doing on the top 20. Yes? Oh, yes, I should. Now, again, I wouldn't have marked this wrong, but I really should have the negative 2 plus 6i. Thank you. And negative 2 minus 6i, because technically the real number is supposed to be first. Good point. Okay, let's go to the next page. This guy. I have a saying that you're going to hear a lot. Get the clump alone. When you're solving, you need to get the clump alone. Here's the clump. Once it's alone, you're going to square root. But if you try to start by square rooting, no, won't work. So, what do I start with instead? Divide by negative 3. And this one is not one that everybody has memorized, but 48 will divide by 3. Anybody know it? 16, very good. X minus 2 squared, the worst squared ever, equals negative 16. Why is it 16? Because it'll take a nice square root now. Okay, solve it. There's absolute values involved, etc. You should be able to do this by now. I've showed you enough of them. But I'll pause while you give it a try. Okay, let's see if you got this down. Square root, square root. Why? Because I got to get the squared off of there. Now it's absolute value x minus 2 equals, and this is not two things here. You don't put a plus minus here. Square root of negative 16 is just 4i. And again, if you were to write that on a test where you say the square root is coming out to two things, I will mark it wrong. I just showed you a minute ago it's not two things. Okay? If we were to graph this, well, you can't actually graph it because it has a negative under the square root, and the calculators aren't as smart as you are. They can't handle imaginary things. So, anyway, now I'm going to split it into two things. X minus 2 is 4i, and x minus 2 is negative 4i. Right off the top 20. Add 2, and I'll try to do it in the right order this time. 2 plus 4i. If you said 4i plus 2, I would have taken it. And negative 4i plus 2. 2 plus 4i, and, oh crap, I put the number last again. 2 minus 4i. There we go. Okay, so that's a typical solving a complicated quadratic. You know how I could have told there was going to be two answers? It's a squared in there. It tells you there's going to be two answers. Okay. All right. And now you have a worksheet right here called Solving with Complex Numbers Worksheet. I think since there's a test coming pretty soon and you have a long weekend, I think it wouldn't hurt you at all to just do all of them. So I'm not cutting this one down. We even got some time to work in class right now. So at this point, I know some of you totally got this. You got the last three problems all right. Okay, well, we were doing on the board. But if you just got the last three problems all wrong and you're like lost, this is a perfect chance. Come up and ask me questions. And then you can turn into that kid who really gets it on the test because you asked. Okay, that's all I got for you for today.